When we're thinking about scale factors, you're essentially saying our original side length times what gives us our copied side length. So one thing that we could do is we could think of this as a basic equation as well. So these are scaled copies. Step 1 says set up an equation where k is the scale factor. So you probably can look at this right off the top of your head and figure out what the scale factor is just looking at the numbers. 3 to 12 or 4 to 16, what are you multiplying by? 4. Our scale factor is going to be 4. Let's write an equation that models that though. So the way we would write this equation is we would say our original side length, so 3, times k is the variable we're going to use for our scale factor, equals, what's the corresponding side that it should equal? 12. 4 is what we're ending up, we're pretending we didn't figure that out in our head. 4 is what our variable should end up equaling. So again, here's our original side length, 3, times the scale factor, whatever it is we're multiplying it by, equals our copied side length, which is 12. Okay? I know we spent a lot of time looking at one-step equations last year. Everyone in this room knew how to do this last year. Eloise, how did we solve this? You had something else to share. Go ahead. Sorry.
I did them in the littler boxes. Is that okay?
That's fine. Yeah.
Oh, wait.
Okay, how do you solve this?
Is that where you put the line?
Absolutely it is. Draw the line. How are we going to solve for k?
And then you divide the 3 by the...
Yeah. Divide by 3 on both sides. Yes, queen. K equals 4. Our scale factor is 4, which is exactly what you told me it should be. Now, step 3 says to reduce fractions to simplest form. That's going to become important when we're getting a bigger original going to a smaller copy. We're going to look at how we can just take those fractions and simplify them to find instead of dividing and getting the decimal in your calculator and then going, what's that equivalent to? Just having the fraction to begin with and simplifying it, okay? Questions on that first one? You could have also set up your equation like this, 4k equals 16, because those are just another set of corresponding lengths. The 4 and the 16 would have worked there. So it doesn't matter which set of sides, corresponding side you pick, as long as you pick ones that match. Eloise?
Could you do like 16 divided by 4 equals 4, and then you do 3 divided by 12 equals 4, and then they're the same, like they're both equal 4,
so 12 divided by 3, yeah, you could, but we're setting it up so that we're solving for a variable is how we're writing it, just like we did last year. Okay, all right, flip to the next one. And it tells us the triangle on the right is a scaled copy of the triangle on the left. So let's start with the one on the left that's getting bigger. So since it's getting bigger, we know when we set this up and solve for k, our scale factor, it should be greater than 1. So does anyone have an idea of how I could set up an equation here? Eva? I'm going to use k again to be consistent, but yes, go on. 3k equals 9. Very good. So these are equilateral triangles, meaning all the sides are the same. So 3k equals 9. Somebody other than Eloise, somebody different this time, tell me what I'm going to do to solve that equation. Scarlett?
Divide by 3.
Yep, you can draw that line in and divide by 3 on both sides. K equals 3. Our scale factor there is 3. Okay. So let's set up the equation. When we're done here, we should have a scale factor that is a fraction. It's less than 1. Okay, so again, you're going to take your original length times your scale factor k equals your copied length. So what does that equation look like when we set it up? Anyone have a guess? McKenna?
Is it the 12k equals 6?
Yes, so our original equation is 12k equals 6. Now watch what happens when I solve this one. It's going to be a little bit different. Elise?
Don't you divide by 1/2 or multiply by 1/2?
We're not doing anything with 1/2. We're trying to isolate the variable. We're trying to get k by itself. So how do I get rid of that 12 that's with the k? Yeah, we're trying to get rid of, remember we're trying to get k by itself. So we have to, instead of multiplying by 12 times k, we're going to divide both sides by 12. Now look how easy it is to find this fraction as we divide by 12. Essentially on the right hand side we have 6 divided by 12, which is the same thing as the fraction 6/12. Instead of turning that into a decimal, let's just simplify that fraction. What does 6/12 simplify to as a fraction? 1/2. So our scale factor is 1/2. We don't have to turn it into decimal form and then turn it back into a fraction. You can just take that and view it as, oh, 6 divided by 12 is the same thing as 6/12. Let's just simplify that to 1/2, and our scale factor is 1/2. Which makes sense. This one is half the size of the original, right? Questions on that? All right, what I want you to do is try, and you can talk to the people around you, set up an equation for the bottom two and solve them. Okay, set up equations and solve the bottom two, and we'll go over and fix them together in just a minute. Okay? Go ahead and do that. I'll give you a couple minutes here. 3 what? Yes. All right. This is the only one I wanted you to look at. Let's see if you got the right answer, and then we'll do the last one together with that fraction, and there's a little goofy. Okay, McKenna, give us your original equation.
85k equals 51.
85k equals 51. When I walked around the room, I saw that most people had this. Are we good with setting up that equation?
Yes.
Okay, we got a little stumped, some of us, on the solving. Okay, so I saw a lot of us dividing by 85. Perfect. So essentially, that equation, or that fraction, is 51/85. You could simplify that all the way down. A lot of you were like, I don't know what to divide those by. So you just divided 51 divided by 85 in your calculator. What did that give you as a decimal? Maddie? 0.6. Eloise, I'm going to use you as an example. She said, I don't remember how I put this as a fraction, but then she read it using good place value language. And how did you read that?
6/10.
Yeah, that's 6/10. 6/10 is just this fraction, 6/10, right? Which simplifies to 3/5. Okay? 3/5. So your scale factor there, your final simplest scale factor would have been 3/5. Any questions on how we got that? Again, we divided 51 divided by 85 and got 0.6. We read 0.6 as 6/10, or we wrote that as 6/10, and then just simplified one more time. All right, this last one has a fraction, so I think some of us are like, ooh, don't know what to do here. Let's start with just the setup. The setup is basic. Tell me who can set up that equation. Elise.
13k equals 13 thirds.
13k equals 13/3. I agree with you. No. It is a good question. If you turn it into a proper fraction, so what we're going to do, so are you talking mixed number? Okay. What we end up having to do is division here, right? If you think back to last year when we talked about multiplying and dividing with fractions, we had to turn them into improper fractions to multiply and divide. So if you turn that into a mixed number, you're going to have to turn it back into an improper fraction when we divide in just a second. So you're just going to give yourself more work. That's a good question, though. Yes, because it feels weird to have it as an improper, right? Okay, so what would we do to solve this here? Do the line, and we're going to divide by 13 on both sides. So we are essentially doing 13/3. I'm going to write this off to the side. Divided by 13, which is the same thing as 13 over 1. So 13/3 divided by 13 over 1. Keep flip change. KFC, do you remember doing that last year?
Yeah.
Okay, so 13/3 times 1/3 is what, 1/13 is what that turns into. Is this ringing bells from last year? Yeah. Okay, so we are dividing fractions. We keep the first fraction. We flipped the second fraction, or found its reciprocal and changed it to multiplication. What happens when I've got two 13s on the diagonal?
You can simplify.
Yeah, get rid of those. Simplify those. It'll make it easier. Turn those both into ones. 1/3. K is going to equal 1/3 here.
How many, wait, what? How's it equal 1/3?
I found the reciprocal. 13 and 13 we can simplify down to ones. So 1 times 1 is 1. 3 times 1 is 3.
Oh, okay. That makes more sense.
So 13 times 1/3 gives us 13/3 for our copied version. Questions on that? So again, we've looked at a couple of different ways to find the scale factor. Before we were just counting sides and trying to figure out what we multiplied by. That's one way to do it. If it was a fraction, we took our copied length and divide it by our original length. This is a third option. You can set up an equation where it's original length times the scale factor of k equals your copied length and solve your equation. And that way will always work if you do it this way. Okay? So what you're going to do is you're going to fold and glue this onto the next page in your notebook. And then you can tuck it into your bookmark.